Hi there. In this video, we're going to talk about z-scores. And this is a tool that we use to determine relative standing. So I want to show you what this is all about. It can be useful to know where a particular data value falls compared to the rest of the data. So, sometimes a particular number by itself doesn't mean a lot, right? But when you compare it to a group, then it becomes more meaningful. So a z-score is one way of doing that. Remember how we calculated the standard deviation, and we said the standard deviation is the average deviation from the mean. Okay, so we're going to use that as a measure. Now, so by that same definition, one standard deviation from the mean is considered average. That's the average deviation. Now, if we get above 2, so 2 to 3 standard deviations from the mean, now is considered unusual. And then 3 or more is considered rare. Okay, so this is just kind of a general guideline. I'm going to put general guideline. But of course, it could vary by the context, so you always want to be thinking about the context you're in and what makes sense for that. Okay, so how do we calculate a z-score? I've got the formula here. What it measures is how many standard deviations a data value is away from the mean. So what we do is we take the data value we're interested in, that's our x. So that's our data value. So each value has a z-score. Take the data value and then we subtract the mean, and then we divide by the standard deviation. Now, we have some different symbols depending on whether we're looking at a sample or a population. So I'm going to write it out for a sample because that's mostly what we have right now. Then we would write z equals x minus x bar, because that's our mean, divided by s. So you might see the formula like that as well. You might also see it with the mu and the sigma if it's in the context of a population or a theoretical distribution, but we'll get to that later. Okay, so let's do an example. Let's continue with our pulse rate data set. Remember, we had 6 students, and we used that to find the mean. Well, actually, we found the mean, but we used it to find the standard deviation. And so our mean was 70 beats per minute, and our standard deviation was 10.64 beats per minute. Okay, so I'm going to do example A in a couple different steps and kind of explain what's going on and why this is useful. And then I'll just put it all together for part B. So find the z-score for the pulse rate of 52. So for the person who had a pulse rate of 52, so I should have put beats per minute on these. I'll edit that in the notes. So for 52 beats per minute, so we're going to take our z equals 52 minus our x value minus the mean, minus 70. So this will be in beats per minute, right? Let me just do this part first. 52 minus 70 is negative 18. Beats per minute. Okay, so that's telling us that this person was 18 beats per minute away from the mean, and they were below the mean. That's what the negative sign means, is below the mean. So the sign is very useful on a z-score. Is it above the mean or below the mean? So negative 18 beats per minute. Now when we divide by our standard deviation, which is 10.64 beats per minute, that will take that distance and tell us how many standard deviations that is. Okay, so let me go ahead and divide that by 10.64, and we get negative 1.69. And after the 9 is a 1, so I don't need to round it up. So negative 1.69. Now, these were both beats per minute, that we divided, so that we don't, the units are not beats per minute. So what I would put for units here is standard deviations, because this is the number of standard deviations away from the mean. So let me move this up a little bit. Standard deviations. And remember, adding the units to everything just helps you understand, helps other people understand what you're doing. Okay, so in general, though, I would do this all at once, but I wanted to show you why it is the number of standard deviations away from the mean. So let's go ahead and do part B all at once. So find the z-score for a pulse rate of 73 beats per minute. So I would do 73 minus 70 all divided by 10.64. Let me put that in my calculator. 73 minus 70. Now I have to hit enter here because if I just do divide by 10.64, it will only divide the 70 by 10.64 because division comes before subtraction in the order of operations. So I would get it wrong. So be mindful of that if your answers aren't making sense. That could be why. You can do it in one step if you put parentheses, 73 minus 70 in parentheses divided by 10.64. So that's another way to do it. And I'm getting 0.281, so 0.28 standard deviations. Great. Okay, so you get to practice doing some z-scores, and we'll use this throughout the rest of the course as well. Okay, see you in the next video.